Hello, welcome to the CCNA preparation guide brought to you by Eduonics. We're on the IP routing technologies chapter here, and we're going to look at some passive interfaces now. So the default passive interfaces feature simplifies the configuration of distribution devices by allowing all interfaces to be set as passive by default. In ISPs or large enterprise networks, many distribution devices have more than 200 interfaces. Obtaining routing information from these interfaces requires configuration of the routing protocol on all interfaces and manual configuration of the passive interface command on interfaces where adjacencies weren't desired. So in a large enterprise network, many distribution devices have more than 200 interfaces. Before the introduction of default passive interface features, routing information could be obtained from interfaces in a few different ways. You could configure a routing protocol such as OSPF on the backbone interface and redistribute connected devices. You could configure a routing protocol on all interfaces and manually set most of them as passive. Network operators might not always be able to summarize Type 5 link states, advertisements, LSLAs at the default device level where redistribution occurs as the first possibility. Thus, a large number of Type 5 LSAs can be flooded over the domain. In the second possibility, the large Type 1 LSAs might be flooded over the domain. The area border router, the ABR, creates Type 3 LSAs, one for each Type 1, and floods them across the backbone. You can, however, have unique summarization at the ABR level, which injects only one summary route into the backbone, thereby reducing the processing overhead. Before the introduction of the default passive interface feature, you could configure the route manually and set the passive interface router configuration command on interfaces where adjacent routers weren't desired. But in some networks, the solution meant configuring 200 or more passive interfaces. The default passive interface feature solves this problem by allowing all interfaces to be set as passive by default. You can set the interfaces as passive by default by using the passive interface default command, or if you wanted to, you could turn it off by doing the no passive interface command. The default simplifies configuration, so to prevent other devices on the local network from learning about routers dynamically, you can keep routing update messages from being sent through device interfaces. This applies to all IP-based routing protocols except BGP. OSPF, Open Shortest Path First, is an intermediate system to intermediate systems behave somewhat differently. In OSPF, the interface address that you specify as passive appears as a stub network on the OSPF domain. OSPF routing information is neither sent or received through the specified device interface. In ISIS, the specified IP addresses are advertised without actually running ISIS on the interfaces. So to prevent that, you could turn it off as well. So here's an example of a passive interface configuration in OSPF. Hello packets aren't sent on a network interface that's specified as passive. However, hence the device isn't able to discover any neighbors, and none of the OSPF neighbors are able to see the devices on that network. In effect, the interface appears as a stub network to the OSPF domain. This configuration is useful if you want to import routes associated with connected networks in the OSPF domain without any OSPF activity on the interface. The passive interface router configuration command is typically used when wildcard specification on the network router configuration commands are more desirable. So this configuration here causes OSPF to run on all subnets of the 172.18.0.0 network. As you can see, it's being set as OSPF area 1 as well. So if you don't want OSPF to run on 172.18.3.0, you could enter this command here and it'll stop it from actually happening. So this example here is the default passive interface configuration for OSPF. It configures the network interfaces, it sets the interfaces that are running OSPF as passive, and then enables the serial interface as well. So you go into the interface, you add that as a secondary, no IP direct broadcast and exit, and the same on the serial. And then you go the token ring interface, root OSPF1, passive interface default, no passive interface for those particular interfaces there. So split horizon is a method of preventing a routing loop on a network. The basic principle is simple. Information about the routing for a particular packet is never sent back to the direction from which it was received. It can be achieved by means of a technique called poison reverse. This is the equivalent of route poisoning all possible reverse paths. That is, informing all routers that the path back to the operating node for a particular packet has an infinite metric. Split horizon with poison reverse is more effective than split horizon in networks with multiple routing paths, although it affords no improvement over simple split horizon in networks with only one routing path. So split horizon routing with poison reverse is a variant of split horizon route advertising, in which a router actively advertises routes as unreachable over the interface, from which it was learned by setting the route metric to an infinite number, which is like 16 for RIP. The effect of such an announcement is to immediately remove most looping routes before they can propagate through the network. The main disadvantage of poisoning reverse is that it can significantly increase the size of the routing announcement in certain fairly common network topologies, but it allows for the improvements of the overall efficiency of the network in case of faults. Split horizon states that if neighbor routing sends a route to the router, the receiving router won't propagate this route back to the advertising router on the same interface. Without route poisoning, the router detects that only one of the connected routes has failed, and the router will poison the route by assigning an infinite metric to it and advertising it to its neighbors. When a router advertises a poison route to its neighbors break the rule of split horizon and send it back to the originator as the same poison route, called a poison reverse. In order to give the route enough time to propagate the poison route and ensure that no routing loops can occur while propagation occurs, the routers implement a hold down mechanism as well.